In this video, I'm going to go over the answers to the test review to make sure that you have the right answers and that you're studying and preparing for the test in the best way possible, so that if you have any questions before the test, that you come to class with them ready to ask and ready for me to clear up so that you can do the best you can. So for number one, it asks you to circle all of the irrational numbers. If you remember, irrational numbers are the numbers that are decimals that never end or do not have a repeating pattern. So because 7.13 has a repeating bar, that's got a repeating pattern. Pi we know is a decimal that goes on forever, so we can circle that. 1/9 is a fraction. Square root of 2, if you type it in the calculator, will give you a decimal that never ends, so that is irrational. 2.1313 dot dot dot, even though you see the dot dot dot, please remember to look for a repeating pattern. That 13 keeps repeating, so that is not going to be irrational. The one next to it, 1.8472 dot dot dot, is going on forever and it has no repeating pattern, so that would be considered irrational. So be very careful between those two decimals. They look similar, but the repeating patterns do not go in irrational. Any fraction is not irrational, so 22 over 7 and 8 over 9, those are both not going to be circled. Square root of 121, if you type it in, is 11. So the only three you should have circled are the ones that are listed on the board. For number two, it's asking you to circle all of the numbers that are rational. So this is the complete opposite. Remember, you want to pick the numbers that can be written as fractions. That means decimals that stop, decimals that repeat, fractions already, or numbers that can be made into fractions. So when you look at the square root of 3, when you type that in the calculator, that's a long decimal that goes on forever, so we don't circle that one. 0 is a whole number, and whole numbers can be made into fractions, so that one should be circled. 5.3434 dot dot dot, again, you're looking for the fact that there is a repeating pattern. The 3-4 repeats, so that is definitely going to be rational. Right? 9.21 has the repeater bar on it, so if you see the repeater bar, you know that's going to be rational. 6.14 is a decimal that stops, so we can make a fraction out of that. Negative 11 is just an integer that we can put a 1 on the bottom and make a fraction very easily. Negative 1/3 is already a fraction, so anything already a fraction should automatically be able to be written as 1. 3.14 again stops, so we can make sure that that can be written as a decimal or as a fraction. Negative 8.34920 dot dot dot, there is no repeating pattern and it goes on forever, so there's no way we can make that a fraction. Negative square root of 25 is the same thing as negative 5, so that one can be made into a fraction. All right, so please know that there are more rational numbers in this world than irrational numbers. So anytime you have to distinguish between the two, you should have more circled in the rational stuff. All right, for number 3, it wants you to select all of the sets to which the number negative square root of 144 belongs. Well, before you can do this, you have to actually figure out what is negative square root of 144. Remember to type in your calculator 144, hit the square root button, and then apply the negative. So you should come out with negative 12 for that evaluation. Right, so we're looking to see where does negative 12 belong to. Negative 12 is a real number because we know everything is real. Negative 12 can be written as a fraction. You stick a 1 underneath it, so it's rational. Negative 12 can be found on that number line, so it's an integer. Negative 12 is not a whole number because it's not above 0, so therefore it's not whole and it's not natural. So you should only have 3 boxes chosen. Make sure you choose all numbers that apply, or all categories that apply. If you miss even one little category, your answer is not correct. For number 4, we want to know which cannot be used to describe the number 14 over 7. Well, first you have to figure out, well, what is 14 over 7? And that's the same as looking at the value of 2. So where can 2 not go? Well, 2 is a whole number, so it goes there. 2 is on the number line, so it's an integer. 2 is not going to be irrational. So that's the spot it does not go to. 2 is real, so then that's the one that goes in. All right. For number 5, you want to look at the entire set and you want to pick out the best classification for all of those numbers, not just parts of them, but the whole entire set. Right? And as soon as I start looking, I know that pi is irrational and I know that 1/9 is rational. So as soon as you see that you've got both types in the same set, you don't even need to look at the rest of the numbers. If irrational and rational are sitting in the same set, the only thing that this set can be is real, because they're not all going to be irrational and they're not all going to be rational. So all they are is real. Right, for number 6, what subset of the real number system is 4? And by subset, we're talking about mainly rational versus irrational. This is the prediction part that we had done in class. So 4 is a rational number. You don't need to list anything else that it belongs to. What subset of the real number system is the square root of 99? Well, that would be irrational. So based on knowing that you have these two types of numbers, which subset of the real number system does the product of these numbers belong to? Keyword here being product. Product means to multiply. So if you did 4 times the square root of 99, your answer will come out some long decimal that fills up your entire screen. The one thing you need to remember is if you multiply or add with an irrational number, your answer will always be irrational. So we're not looking for a numerical answer, we're looking for an actual subset or category answer for that type of problem. And you will have one just like that on the test with different numbers. For number 7, why is 0.184 ... considered an irrational number and not a rational? And then you need to write this in your own words. Right? The first thing that comes to mind, it's irrational because it is a decimal that never ends and has no repeating pattern. And this is basically just your definition for the word irrational, so that will justify why that number fits in that category. Now, the reason it does not belong in the rational number category is because it cannot be written as a fraction. So as long as you have some sort of wording that involves these two statements involved in your answer, then you would get credit for that answer. Right, number 8, which of the following sets contain only rational numbers? So we're looking for only numbers that can be written as fractions. Right? Well, if we look at letter A, 3.14 can work. Square root of 100 is 10, so that would work. 2.4545 ... Notice there's a repeating pattern, so that would work. And negative square root of 25, which is negative 5. All 4 of those numbers can be made into fractions, so A is the correct answer. But if you look at letter B, there's pi in there, that wouldn't work. In letter C, there's the 3.9352 ... That wouldn't work. That's what throws that one out. And in letter D, pi's in there, so that would throw that out. Any irrational number shoved in those selections would make that a bad choice. So A is the best choice because all those numbers are rational numbers. Right, if you look at number 9, now we switch to a different topic. And this is how your test will be broken up as well. Which of the following is between 21 and 22? Right, so when you hit the square root button of each one of these on your calculator, you want it to say 21 point something and not 22 and not below 21 either. So once you get those 4 values checked in your calculator, the best answer is B on this one. The square root of 444 will fall between those 2 numbers. For number 10, the area of a tablecloth is 36 square feet. What are the dimensions of the tablecloth? If you remember back to the very first lesson we did where we drew squares on graph paper, right, and you had an area inside, you're trying to figure out what is the outside side measurement that would make this happen. So if I have 36 inside, then each of my sides has to be 6, because 6 times 6 would be 36. Right? So that would be letter B as your answer choice. Number 11 wants you to identify all the numbers that are perfect squares. Remember, for perfect squares, if you type the number in and hit the square root button in your calculator, if it gives you a whole number, you know you've got one. If it gives you a decimal, you know you don't have one. So if I do the square root of 25, that gives me 5. If I type in the square root of 136, I get a decimal, so I don't want that one. If I type in square root of 81, I get 9, so I want that one. Square root of 221 gives me a decimal, so I don't want that one. Square root of 324 is going to give me 18, so I want that one. Right? So test everybody because you don't want to leave anybody out. For number 12, okay, it wants to know the square root of 50 lies between which 2 consecutive whole numbers. So when you go to type in the square root of 50 in your calculator, you get 7.07 ... Okay, so remember that the first number in front of the decimal guides where you start, so you have to start with 7, and right behind 7 on the number line is an 8. So it has to be between 7 and 8. For number 13, the square root of 81 is, and here's where you've got to be super careful, because if you just type in the square root of 81, your calculator is only going to tell you positive 9. But remember that 9 times 9 is 81, but negative 9 times negative 9 is also 81. So as long as it's just the square root of 81 and there's no extra negative hanging out on the outside, you have to pick both answers. It can be both the positive and the negative version. Okay. For number 14, this time we want to identify all the numbers that are not perfect squares. So again, you want to go back to your square root button on the calculator. Square root of 49 is 7, so we don't want to pick that one. Square root of 729 is 27, so we don't want that one either. Square root of 122 comes out to be a decimal, so we want that one. Square root of 198 comes out to be a decimal, so we want that one. Square root of 441 is 21, so we do not want that one. Be very careful. The key word is not. If you see that word there, make sure you're picking the right answers for the right choices. All right, for this bottom section right here, we did a lot with properties, so you have to know your properties in terms of which ones are which. And all I'm asking you to do in these two problems is to give examples of each one, and your examples can be way different than mine as long as they do what they're supposed to do. So I'm pretty much going to give you just some basic ones so you have something to go off of. For commutative, we want to do addition and multiplication. So for addition, 2 plus 3 equals 3 plus 2. Remember, that's where your order changes. For multiplication, you can do C times D equals D times C, right? So that's easy for multiplication. For letter B, the additive inverse, or the inverse of addition, says that if you take a negative number and you add its positive version to it, you end up with 0. So look for the negative and the positive version of the same value. For the distributive property, you have a number or letter on the outside and you have some addition or subtraction statement inside. That number on the outside is given to both things inside. So in this case, it would be 7 times A minus 7 times B. Okay. Just make sure you're looking for that same number being used twice. For letter D, this is the multiplicative identity property, or identity of multiplication, if you want to say it that way. And that's where you start with some value. So I'm going to start with the letter K, and I'm going to multiply by something to still end up with K. Well, an identity property, in order to get the thing you started with, you have to multiply by 1. So look for that times 1 piece. All right, for number 16, here's the rest of the properties, and again, you're just going to give examples of them. So for the associative property, we want to do addition and multiplication again. So again, I'm going to give you some pretty basic ones. So 2 plus parentheses 3 plus 4 equals parentheses 2 plus 3 plus 4. Okay, so remember, in associative, you're looking for the order to stay the same, but what's in parentheses is doing the changing. So on the left, 3 plus 4 were friends. On the right, 2 and 3 are now friends. So the friends change. That's what you're looking for. So in multiplication, it could look something like this. A times B in parentheses times C equals A on the outside and B and C in parentheses now. So the friends have changed, but the order still stayed the same. For letter B, the multiplicative property of 0 is what's known as your 0 property, which you've learned this since kindergarten. Anything times 0 is 0. Okay, so that's what you're looking for, is that times 0 equals 0 piece. For letter C, there is a bit of a typo here. It should be the additive property. Actually, it should say the additive identity property, because this is the one that's missing. All right, so this is your identity of addition, because over on the other side we did the identity of multiplication. So in the identity of addition, you would take any number you want, and in order to get the same number on the other side, you have to add nothing to it. So this is where you add 0 to get the same number to come out on the other side. And then for letter D, the multiplicative inverse property, or inverse of multiplication, that involves your fractions and reciprocals. So if you have 3/7 and you multiply by 7/3, you always get 1. Right, so that's where that comes from. So these are the properties you want to make sure you know something about, and that you can distinguish the difference between the two. Right? If you go to the next set of problems, you're going to have a chart to choose from, and there's examples in each box, and for each question you're going to have to pick which ones follow which properties. So for number 17, we want to know, out of all of these statements A through H, who is demonstrating the commutative property. It doesn't matter if it's of addition or of multiplication, it's just the commutative property. So we're looking for order to be changing. So if you look at letter A, the order did not change. It says ABC, ABC. If you go to letter B, it says ABC and CAB. So that one, and all you have to do is write the letter, not the actual example, right? That one is commutative of addition. If you go to letter C and you read the order, it says 374, and then on the other side 374. That's not commutative. If you go to letter D, it says A8D, 8AD. The order changed. So that one is definitely commutative. That's letter D. Go to the next row. For 15, right, you have 15 plus 10 plus 0 equals 15 plus 10. There's not anything to show that that's commutative. The order didn't change. For letter F, 374 and 743, the order did change. So F is another one. That one's commutative of multiplication. If you look at letter G, it's 6AB and 6AB. So the order did not change. And letter H, the order did not change. Okay, so for number 18, we want to choose from the same set of boxes the ones that are showing the distributive property. Remember, distributive property is when a number outside parentheses is given to both things, right? Well, the only ones that you have numbers outside parentheses that this could even apply to is letter H, right? That is the only one that is showing the distributive property. 9 times A is what makes your 9A, and 9 times 4 is what makes your positive 36. All right, so another way this could be written is 9A plus 9 times 4. They just went ahead and made 9 times 4 turn into 36, which you'll be able to do here in a few months as well. All right, same directions, just different examples now for the bottom section. All right. So for number 19, we want to find all the ones that demonstrate the identity property of multiplication. Identity of multiplication says anything times 1 gives you the same thing you started with. So you're looking for the times 1 feature. A doesn't have it, B doesn't have it. Look at C. 6A times 1 is 6A, so C is going to be it. Look at D. 1 times AB equals AB, so it doesn't matter where the times 1 is, front or back. That's still identity of multiplication. And if you look in the bottom row, there is no times 1, so none of those apply. For number 20, right, we want to pick the ones that demonstrate the inverse property of addition. Inverse of addition says that a number and its negative version makes 0. So if you look at letter A, -1 plus +1 is 0, so that's inverse of addition. Okay. If you look at B, that's adding 0, so that's not inverse. That's identity of addition. If you look at E, that is inverse, but that is inverse of multiplication. Make sure you're paying attention. I said inverse of addition on the problem, so that's the one we're looking for. Letter F is not a property of any kind. If you look at letter G, you've got +8 adding to -8, so that one is inverse of addition. And if you look at letter H, you have ABC adding 0 to get ABC. That's identity, not inverse. Right, so hopefully you've seen enough here to give you a good feel of what your test is going to be about and what you need to study and prepare for so that you do a good job on this first test of the year.